Relating the basics of trigonometry, the first word that should come to mind are right-angled triangles. What are right-angled triangles, you may be wondering? A right-angled triangle, or a right triangle, is a triangle in which one angle is supposedly a right angle. The relation between the sides and angles of a right triangle is the basis for trigonometry. The question for this section is, what is the history behind the development of trigonometry? Essentially, it was originally created by the Greeks to aid them in the study of astronomy. In later years, around 190 to 120 before Christ, Hipparchus of Bithynia used it to tabulate trigonometric ratios to successfully measure the calculation of our planet's position. It was the Chinese that invented the tangent function, which we will be discussing later on in further sections. Let's take a look as to how to label a right-angled triangle, or in any case, a triangle. So this is a right-angled triangle because I know that angle C is actually 90 degrees. And so that's where I begin. First, I look at the vertices. I know that this is A, this is B, and this is C, so I could call this triangle A, B, and C. I can call this angle, angle A, this angle, angle B, and this angle, angle C. A way to write this is angle C equals to 90 degrees, and this information tells us this value. Now to name the lengths. AB is opposite of angle C, therefore we can call it little c. Angle A is opposite of length CB, so we can call this little a. And angle B has an opposite length of AC, so we could call this little b. Now we've named all the external values, let's look at the inner values. We already know this is 90 degrees, and we already have a name for each of these and each of these. Now what we need to do is figure out what to name these angles. We use a variable known as theta to classify an unknown angle. Theta could be this, theta could be that, depends on what you're solving for. So theta is actually the 8th letter in the Greek alphabet, and back in ancient Greece, it was classified to be used as anything. And since we follow a lot of Greek mathematics, we just decided to stick with theta. Theta tells us that this angle is unknown, so when we solve for certain trig problems, we can use theta as our beneficial tool. Theta also helps us with another thing. It helps us classify what side is what. The length opposite of theta is always the opposite side, so in short, OPP. The length beside theta is known as the adjacent side, so we can call it ADJ, in short for adjacent. And the last length, which is opposite of the 90-degree angle, is known as the hypotenuse. We've also heard this word when we've done Pythagorean Theorem. A square plus b square equals c square. The c square actually represents the hypotenuse, which is the greatest length. An example I can give you is the following. The length that I'm drawing right now, right here, is the c square, or the c, or the hypotenuse, and its value is always greater than a and b. This symbol here, the greater or equal to, represents that a and b could either be the same length, it could be greater, it could be less, but in the end, length c is always the greatest. In order to start the introduction of trigonometry, part 1, let us use the previous knowledge in the last section to quickly label this triangle. So this is A, B, C, so we know that's triangle A, B, and C. Angle C is 90 degrees, we know angle A is 74, and this is unknown. Opposite of angle C is little c, opposite of angle B is little b, and opposite of angle A is little a. Now that we've labeled this, let's figure out where to label theta. Let's use angle A as theta. I know previously I mentioned that theta is used to represent an unknown angle. However, in this case, we're trying to solve for the length of CB to see how far the acorn is from the tree. This type of problem is quite hard to solve considering we haven't looked at trigonometric ratios, and that's what we're going to be doing right now. There are three different ratios that are associated with trigonometry. They include the sine ratio, the cosine ratio, and the tangent ratio. For today, we're going to be solely looking at the tangent ratio. So let me just erase this. The tangent ratio is written as opposite over adjacent. So before I go over what this whole thing means, let's look at what ratios are. A ratio is one quantity compared to another quantity. For example, 4 ratio 3. This can be represented as in a fraction as well, 4 over 3. Another example could be 100 ratio 1000. This can also be identified as 100 over 1000, or if we simplify it, 1 over 10. This value and this value are equal. Now let me just erase this one last time. When I mentioned the tangent ratio, I meant the opposite side versus the adjacent side. In the last lesson, we looked at theta and its benefits on the side lengths. So opposite of theta is the opposite, and adjacent is right beside it. And then lastly, this is the hypotenuse. But once again, for tangent ratio, we're only looking at the opposite side and the adjacent side. For this question, let's take a close example. Tangent of theta, so tan, the short form of it, tan theta, can be replaced as tan 74. That's because we know theta is 74 degrees. We also know one of the sides, the opposite or the adjacent. We actually know the adjacent side, which is 14 feet. So let's plug that in. Tan 74 degrees is equal to the opposite side, which is A, so we don't know that, so we simply write A, over the adjacent side, which is 14 feet. Now we want to solve for A, so we have to move the 14 to the other side. So what we can do is we can multiply both sides by 14 to isolate for A, and you would get 14 tan 74 degrees, which is equal to A. So if we plug exactly that into the calculator, 14 tan 74, we will get approximately, so when we write approximately, we put a dot over the equal sign to represent approximity, and we write 48.8 feet. So what this tells us is the length of this, length of CB, or length A, is 48.8 feet. If we know that this is 48.8 and this is 14, how can we solve for A and B? Well, as we previously knew, we could do the Pythagorean Theorem. So we know the Pythagorean Theorem is A squared plus B squared equals to C squared. c squared, b squared, and c squared. A squared is 48.8 squared plus b squared, which is 14 squared, is equal to c squared. 48.8 squared is approximately 2381 plus 14 squared, which is 196. Once again, we're solving for c, so we have to isolate just c. At the moment it's c squared. So what we do is we actually take the square root of both sides. So c squared is square root plus the value of 2381 plus 196, which is actually 2577. So let's take the square root of that, and therefore c is equal to the square root of 2577, which is 50, which is approximately, put the dot, 50.7 feet. So now we know that the hypotenuse is 50.7 feet. Look closely that the hypotenuse is actually the greatest length compared to the 14 feet and the 48.8 feet. And this is one of the more easy problems when it comes to trigonometry. We use the tangent ratio for this, but there are other methods that we can use, which as I included in the beginning, sine and cosine.